Today we'll see Unit 3, Part B is Integer Linear Programming. So in this Integer Linear Programming, we have actually more problems itself. So here we will be solving the linear programming equations and we will be using first the graphical method to solve the linear programming problems. So you can observe here it is integer. So all the decision variables x1, x2, any other decision variables value we have to get integers. So let us consider the equations. Maximize f of x equal to 3x1 plus 4x2 subject to the constraints 3x1 minus x2 less than or equal to 12, 3x1 plus 11x2 less than or equal to 66, x1 is greater than or equal to 0, x2 greater than or equal to 0, x1 and x2 are integers. Solve using graphical method. See, you can find the difference here in the linear programming problem given itself. See, we used to have till here in all other problems, but you can observe here x1 and x2 should be integers. See, whenever you solved using the simplex method, we used to get these x1, x2 variables as the answer as x1 is equal to sometimes 13.2 or x2 equal to sometimes 5.9. So, in this case, we have to get the x1, x2 value integer itself. So, first, we'll illustrate this solving of the integer linear programming equations using graphical method. To solve using the graphical method, let consider the first constraints. Okay, don't consider this objective function. Let consider the first objective, the constraints 3x1 minus x2 is less than or equal to 12. To solve using the graphical method, let consider this is equal to 12. So I will solve here itself. See, I am writing the first constraint 3x1 minus x2 is equal to 12. Okay, this is, I am equating this because I want to solve this one using the graphical method. So, in this equation itself, let consider x1 equal to 0. So, if x1 is equal to 0, what is the x2 value? Since we have minus symbol here, minus symbol goes here, so x2 will be minus 12. Next, let consider x2 is equal to 0. Okay, now what is x1? So 3x1 and minus x2, so it is equal to 0 equal to 12. So what is x1? x1 is equal to 12 by 3, you will get equal to 4. Now write one set of the values of x1 and x2. x1 is 0 here, x2 is minus 12. Here in this case, x1 is 4 and x2 is equal to 0. This is one set of points to draw by using this graphical methods. Next. Now, similarly, you find out, let's consider the second constraints. 3x1 plus 11x2 is less than or equal to 66. So I want to solve this. That is the reason I will consider this is equal to 66. So similarly, how we have done for the first constraints. So similar to that, you do let x1 is equal to 0. Then what is x2? x1, if it is equal to 0, x2 will be 66 divided by 11. So 66 divided by 11 gives you 6. So what is 1 point? x1 is 0, x2 is 6. So how we have considered x1 as 0, in the similarly considered x2 equal to 0. So now if x2 is 0, what is x1? 3x1 equal to 66. So 3x1 equal to 66. So x1 becomes 22. What is our second point? 0. So first I have to write x1 value. So here it will be 22, 0. Okay. Now you have to plot this values. See, you can observe here, this line represents the equation for 3x1 minus x2 is equal to 12, and this line represents the 3x1 plus 11x2 is equal to 66. And I have plotted the graph here. I will get a coinciding point here. If you measure this value, you will get 4, x1 is equal to 4 1 by 2 and y will be equal to 5 1 by 2. If you substitute these values in our objective function, you will get the maximum value is equal to 34 into 1 by 2. So same thing. Now I will solve here itself. I'll erase this one. So now, consider these two equations. So now, since I have to solve this, I will consider this is equal to 12 and 66. Let subtract this. So what happens if you subtract this? So 3x1 minus 3x1 you will get 0, minus x2 minus of 11x2. So this becomes 12x2 equal to, this is minus. So 12 minus 66. So you will get 54. Correct? So x2 will be equal to 54 divided by 12. So 6 9s are 54. So you will get, if you represent this in fraction, you will get 2 4s are 8, remaining will be 1. x1 will be, x2 will be 4 and half. So if you substitute this value in any one of the equation, you will get x1 value. So I'll substitute the value of x2 in the first equation. So I'll consider the first equation. So if I consider the first equation, then 3x1 minus x2 value. So I'll consider this 9 by 2 equal to 12. Okay. Now if I solve this one, 3x1 equal to 12 plus 9 by 2. Okay. So if you solve this one, you will get 24 plus 9. So 24 plus 9, you will get 33. 24, 33 by 2. Okay. Now x1 will be, see 3x1 is equal to 33 divided by 2. Therefore, x1 will be 33 divided by 3 into 2. So this is equal to 11. So x1 becomes 11 by 2. So this I can represent this as 2 5s are 10. So 5 1 by 2. So here I have solved. See, you have to use the graphical method to solve this one and you will get the same points here. Similarly, otherwise you can solve these two equations and we will get the answer of x1 as, I will erase this part. X1 as 5 1 by 2 and x2 as 4 1 by 2. Now, I will substitute this to our objective function. So, f of x is equal to, what is the value of the objective function? 3 into x1. x1 is 11 by 2 plus 4 into x2 is 9 by 2. So, I will get here 33 divided by 2 plus 36 divided by 2. So, here I will get 69 divided by 2. Correct? I will get 69 divided by 2. So, if I have to represent this, so this will be 2 3s are, 2 4s are, remaining one 34 and half. Now, if you observe here x1 is 5 and half, x2 is 4 and half and your objective function is 34 and half. But what is this? The programming says, this problem says the value of x1 and x2. If you see the problem, it clearly says x1 and x2 should be greater than or equal to 0 and x1 and x2 are integers. But if you observe here, x1 and x2 are not integers, they are fractions. So what we have to do to convert this into integers, let us make an assumption by truncating this fraction parts. Okay, truncate these fraction parts which are present in your x1 and x2 values. So assume here we have truncated because we want here integers. x1 and x2 should be integers. So x1 is equal to 5, x2 is equal to 4. So I have considered only the integer part of our actual solutions. Now if x1 is 5 and x2 is 4, what is our objective function? F of x is equal to 3 into x1 plus 4 into x2. 15 plus 16. You will get 31. So, if you observe, x1 is 5, x2 is 4. In this case, if I substitute everywhere here, 3 into x1. 3 into x1 is 15 minus 4. It is 15 minus 4 is 11. So it is less than or equal to 12. It is matching this constraints. So 3x1. And similarly, if you check this with this also, it is matching with the constraints and our objective function is 31. But always we cannot make an assumption to truncate the values of this the solutions by truncating the fraction part of the actual solutions. It may or may not fit properly and sometimes we may not get actual feasible solutions. That is the reason we will be solving the problems, the same problems, using the two more methods called as Gomori cutting plane algorithm and the branch and bound algorithms. So here, integer linear programming, this I have solved using the graphical method. If you solve using the graphical method, x1 and x2 values may not be integers. That is the reason I have truncated the fraction part here. Even though I have truncated the parts and after getting this objective functions, sometimes For this problem, it is the x1, x2 value and the objective functions, it's matching with the constraints. But always this solution will not be the feasible and optimal solutions. That is the reason we have to go for Gomori's cutting plane algorithm, as well as one more method called as branch and bound algorithm. Thank you.